So, what in the world is the inverse of a function? Well, I'm glad you asked. All my pencils have been disappeared. Okay, so. All right, inverse functions, guys. It's basically when you swap the x and y value. So what happens when you graph a original function and its inverse? I'll actually show you. Let's pick a good one. I'll show you on the graphing calculator kind of what it looks like. So, let's just do the first one. F of x is the same thing as what?
Y.
Yes, it's the same thing as y. So that's the same thing as y equals negative x to the fifth. So if I need to find the inverse of a function, there's really only two steps. First step is to literally swap x and y. So find the inverse. Step one, swap x and y. So when I do that, check out what it looks like. So instead of writing a y, I write an x. Instead of writing an x, I write a y. Okay, so there's the first part. I have swapped x and y, and now all I need to do is solve the equation for y. Solve for y. So if I want to get y by itself, what would you do first? Yes, I would divide both sides by negative 1, get a negative x equals y to the fifth. What? Oh. And now, if I want to get y by itself, how do I undo?
1/5.
Yes, I could raise both sides to the 1/5 power.
Wait, how did we get negative y to the fifth?
So this is just the original.
Yeah,
You swap x and y.
y.
That's step one. That's how you find the inverse.
Oh.
So now I'm here, negative x to the 1/5 power. We should put the negative x in parentheses too, because it's actually isn't going to end up mattering, but whatever. All right.
Y, it's negative again.
Huh?
X is negative.
So you understand this line right here? X equals negative y to the fifth?
Sort of.
Because you just take the original and you swap the x and y. But now I need to get y by itself, so I divided both sides by a negative.
Oh.
And then to get rid of the 5th power, I raise both sides to the 1/5 power. So now what I want to do is graph the original and graph the inverse on the same graph so you can see what they look like. So the original one was negative x to the 5th power.
Well, it looks like it's solved for y.
Yep, solve for y. And then our second one now is going to be negative x raised to the 1/5 power. All right, so you can see I have them both typed in here. When I hit graph, it's going to do the first one first, the original, and then you'll see the second one pop up. Okay, ready? Well, buckle your seatbelt because... So there's the original, and then there is the inverse.
Oh, are these gonna get us the sideways things?
You can, yep, you can get sideways things here. So, what do you notice about these two graphs, or is it?
Both functions.
These are both functions, you're right. Is there something else that you see, Cody? So they look like they might be, but there is something to what you're saying.
They're the same.
They're-
Just different.
Just rotate.
Yes, and they are rotated basically 90 degrees. So what they are is they are reflected over the y equals x line.
Oh, I got that on MCAS. I did not know what that was.
Really? Oh, see, we should have done this on Monday. You did?
4-part interest.
Oh my god, me
Yeah.
too.
No idea.
But they gave you the equation.
Yeah, you just had to plug in, but it was still confusing.
So let's try another one. And we'll see in a different style graph. So again, we have this line y equals x. So it's basically a line of symmetry. So if I were to take an original graph and fold it over this line, I come up with its inverse. All right, so let's try another one. Let's try, oh, I don't know. Let's try one like number 4.
What was the final answer?
Oh, this right here. So let's look at number 4.
I just got confused on the last word, but the rest was really easy.
Okay,
Thank you.
you're welcome. All right, so let's see if we can write the inverse of this. Remember, the original is really just a y negative 1/4 x plus 1. So take a minute and see if you can follow the steps. So there's our original. Now swap the x and y and then solve for y.
Do you have to change the +1 when you switch it?
No, when you switch, you literally just write x instead of y, and same thing over here.
Does y become negative again though?
Well, it's going to do whatever it has to do in order to get y by itself.
Oh, so yeah, subtract.
So let me see. So first everybody wrote this, right?
Well, no. Yeah.
So step 1, literally you write the same exact equation, you just swap x and y. No, you just switch the letters x and y. Everything else stays right where it is. And then I just solve this for y. So I got to get rid of the 1 and I got to get rid of the negative 1/4. Okay, everybody got an answer?
Yeah.
So, you minus the 1 first, right? So now I have x minus 1.
By the negative first, too, and then just divide by -1. Negative is going to go by 4.
You can, but did you change that to a negative also? You can do that. So now I'm here, and then I could get the y both sides by multiplying both sides by negative 4. So multiply u by a negative 4 and u by a negative 4, which means I'm going to have to distribute, right? So hopefully you got negative 4x plus 4 equals y by itself. So now I have my inverse to the original. So again, I'll show you the graph of both of these, and we should be able to see again, they're going to be the same graph, just reflected over that y equals x line. So let's put in the original was a negative 1/4 x plus 1. And our second one is negative 4x plus 4. Okay, ready? Okay. There's the first line. And then there's the second. So could you see if I folded along this diagonal how they'd make these, it'd be symmetrical over that line?
You know, I think I might have just guessed right on every test.
Oh, good.
But then, thanks. It was like one, I had to like write out the answer E. I think I just typed in letters.
Well, you also got to think, like, I don't know. I don't understand NCAS and why it is the way it is.
I think it's stupid.
It makes no sense. When I was in high school in New York, whenever you take Algebra 1, you take the Algebra 1 test. Whenever you take geometry, you take the geometry test. It's not, because kids are in all different places at 10th grade. So you guys are lucky because you've at least taken the majority of Algebra 2. There are kids in 10th grade that they're not even done with Algebra 1 yet. They're not even taking geometry. I had a poor kid, I was proctoring, and he said, how am I supposed to answer this? I've never taken geometry. I don't know, kid, I don't know what to tell you. I think it's crazy. I don't know, that's just my opinion.
Common sense.
Wow.
Some of it is.
Okay, so, we get the idea? All right, let's try a tougher one. How about,
17.
5. 6.
I'm thinking 6 too.
No, 3. 3.
Could Would you
it's
keep
three.
28?
No, not three.
Yeah, 3 looks a little.
Three looks
Alright.
a little tricky.
It just looks worse than it is, but we can do it. So g of n, again, that's the same thing as y. So I've got, here is my original. And I know they have an n instead of an x, whatever. So I'm just going to, instead of n, I'm just going to put an x. I hate when they don't use x and y. But whatever, same thing. So if I want to find the inverse, I'm going to swap those two. So step 1, x equals the fifth root of y plus 3 plus 2. Well, if I want to get y by itself, what are you going to do? Yep, let's start by minusing the 2.
Wait, so like when you switch the x and y,
Yep.
you don't have to like make one negative or anything.
No, I literally just switch those two letters. Okay, I'm still trying to get y by itself, so now I need to,
One set.
great question. How would I undo a fifth root?
To the
One
fifth
fifth.
power.
You raise it to the fifth power.
Now I just feel stupid.
Don't. Now, look at this left-hand side. You have to put that in parentheses. You
That's a swap.
have to put it in parentheses. Otherwise, you're just going to raise the 2 to the fifth and not the x minus 2. So it's the whole left-hand side you're going to raise to the fifth power. So now I'm here. I have x minus 2 raised to the fifth power. And now the fifth root raised to the fifth cancels out, and I just have y plus 3. So,
You literally have to do
huh?
the 2 or the x minus 2 to the fifth. You have to do that.
No! I just got to write my equation so that y is by itself. So the only thing left to do is minus the 3. So I'll have x minus 2 to the fifth minus 3. And there is my inverse function.
And then we literally just type that into the calculator.
Well, me typing in the calculator is just to show you that they reflect over that line.
No, we don't get calculators till tomorrow.
So I'll show you this one too. So let's see. I need the fifth root. So I think I have to put in 5 first. Hang on, I gotta remember how to do fifth root. Let's take the fifth root of 32 and make sure it comes out to be 2. Yep, okay, that's how you do it. So fifth root, oops, of n plus 3, which is really x plus 3.
You're so mad yesterday. I was drinking the coffee.
I was so mad. I look, here comes the
Plus 2.
issue again.
Okay, and now this one, I want x minus 2 to the fifth minus 3. Okay, ready?
No.
Let's see. Ooh. Oh. Very fancy.
Their new shapes are kind
Wrong.
of, yeah.
So, again,
It's got like
if I have that diagonal line, y equals x, you can see how they're symmetrical over that line.
I'm gonna start making us find like the cross.
No. The only things we do with these inverses are find the equation of the inverse, and then let's take a look at the back side of this.
Can I go film a water bottle?
No.
You better hurry because you're going to miss how to do the back here. So now they give me two functions, and they're asking me, are they inverses of each other? So, you have some options here. Are you listening? Are you listening? Oh, good. Great.
My ears are wide.
So one option is to take one of them, find its inverse, and then see if the other one that they gave you is the same as what you came up with. Or, ready for this? You can do function composition. If f of g of x comes out to be a -1, They are inverses of each other, yeah.
I think you might have skipped one of the hats.
Oh my gosh, and you're just telling me now?
Well, I didn't even notice we were doing it. I'll give it to her.
Okay.
You are going.
Okay.
I caught it. Proud of you.
All right, guys, so we're going to take one function and put it in the other. It doesn't really matter which one you put into the other one, so I would try whichever one's kind of easier. It looks intimidating, but they're not so bad. In fact, let's start with number 10. All right, so here's what I'm going to do. I'm going to take this whole thing, right? I'm going to take G, and I'm going to put it into the f function. So that means in the f function, I'm going to replace the x with all of this. You with me so far? So I'm going to take the g, and I'm going to put it into the f. So I'm going to write 3 minus, and then instead of writing x to the third, I'm going to write this whole thing to the third. So the cube root of negative x plus 3 to the third. Yes, so I get... Now it's 3 minus this, right? So it's going to be 3. Well, let's just do this part.
Wait, so now we don't have to swap x and y?
Nope.
Would that make it positive?
Mm-hmm. So I had to distribute that negative, so now it's 3 plus x minus 3.
So just x.
I just get x. Oh, you know what? Now I'm forgetting. Are the inverses supposed to equal x or negative 1?
Oh my.
Shoot.
You're going to screw it all up.
I know. Crap. I know.
Oh,
To ask if it
you,
equals
that's what you
x.
look like when we do ladders.
What?
We do ladders and sports with your hands like,
Yeah, I know. I don't care.
it's so funny. You just have one hand's doing it, the other hand's like flopping by itself. I'm like,
What is this? What am I sending you? What's this?
This is easy.
The same one.
what did I send you? What do you
Me
mean?
drinking the coffee?
Oh.
Wait.
You're bad about that.
I was mad about that.
Why?
Because -4 every time I asked for it, no, I did. And then one day
Sorry,
I
it's
told
X.
you, you're like,
It's
"Oh,
X,
I
it's
got
X.
cookies today."
It's x. Which makes sense because we're supposed to see does y equal x. So change this up at the top, not a negative 1. I think I was thinking about if two slopes are perpendicular, you multiply them together and their product's -1. I think that's why I had -1 in my head. We're going to go with that anyway. Yes. So that means that these two functions in number 10 are inverses of each other.
Can I use the lube?
Would
You
this,
better hurry. Yeah.
would this be y equals all of that? So it's y equals x or no?
Where? Oh, right here?
Yeah.
No, because you're going to take one and put it in the other and see if it simplifies down to be x. Yep.
You're in MCAS.
Terrible.
Oh, that's okay.
I don't.
Okay, let's try. I'm looking at these and there's not. These are all kind of tough. So what I want to do first, let's just do another easy one.
I mean, we're not gonna have them for homework.
Oh, you never know what you'll have for homework.
Stay here.
What time does this even end?
08.
No.
Oh.
Oh, that's right. Oh, yeah, because now we have first lunch, so.
I already finished the whole front
What
side.
time does it end?
I found this easy.
Good.
2?
So, let's try it with these ones, guys. So, f of x equals -1/4 x plus 1. And I know this one should work out just fine because I know that these are inverses of each other.
Is this 9?
Well, no, it's not really on the sheet at all.
Oh.
I just took ones from the front. So I know that this is supposed to work out.
I need a place to write this. Wait, is that a problem here or did you just make that up?
It's not really it's a problem from the front, so I know that the answer should be yes to this, but I'm going to pretend like I don't know.
Is it number 4?
Yeah. So, are these inverses is the question. Again, we already know that the answer is yes, but we're going to make sure that we know why. All right, so I'm going to take one of them and I'm going to put it into the other one. So, I don't know, it doesn't really matter. Let's take this one and stick it in there. So I would do negative 4 times negative 1/4 x plus 4, and then plus 1. Does everybody see that?
Wait,
I took one function and I stuck it in the other one. So I have negative 4.
shouldn't that be a 1 on the inside?
Oh yeah, sorry, thank you. Good catch. And then this should be a plus 4. Gosh.
Can you do one where x is like in fraction?
Yep. I'm going to rewrite this because I don't like that I messed up.
Look at that, it works. Hey.
So let's distribute that 4. Negative 4 times negative 1/4 is a positive x. Minus 4 plus 4. Oh, well, what do you know? Hooray! So they are inverses of each other. Yes!
Can you do 7?
Sure. So let's look at 7. All right. Again, they look kind of bad, but they're not as bad as you think. So, is everybody ready?
Did you multiply by x?
Well, I'm going to take this one, and I'm going to stick it in there. So, I now have 4 over negative 4 over x plus 1 plus 3. And then I'm going to minus 2.
Somehow I froze. Wait, why do you put the plus 3?
Because I took this one and I replaced, yep.
If you replace the top on the bottom, what would it do?
So
I just went up and did it.
I'd have negative 4 over x plus 3 minus 2 plus 1.
Okay, that's what but I wasn't sure that
Okay. You with me so far? All right. So here, 1 plus 3 is just a plus 4, right? Plus 4. I need to add these two fractions together. Well, that's not a fraction yet, but I have negative 4 over x, and I want to add 4 to it. So how am I going to add these two together? Yes. So right now its denominator is 1.
multiply by x.
Yes, so multiply by x over x. So now I have 4 over negative 4 plus 4x,
Can you move it down a little bit?
yep, all over x. And then I'm going to minus 2.
It's a lot for me to handle.
If I have a fraction and a fraction, can I do cube change flip? So keep the numerator, change the multiplication, and then flip the denominator. So now I've got
Wait, what do you do?
keep change flip when you have a fraction and a fraction. See how I have a fraction inside of a bigger fraction? Well, you can't have that. So to fix it, isn't dividing by a fraction the same thing as multiplying by the reciprocal? So there's a saying, keep change flip. You never heard keep change flip? Oh yeah.
I just don't get what you keep.
You always keep the numerator, you change the division to multiplication, and then you flip the denominator.
Oh, so you just listen. Oh,
So we keep the numerator as 4. I change it to multiplication, and then I flip this, x over negative 4 plus 4x. And then I'll still have to minus the 2. Okay, you with me so far? Okay. Now, I'm going to multiply these two together. So that's just 4x over negative 4 plus 4x. Minus 2. Can I do anything else with this? Yeah, they all have a 4, so I can divide everybody by a 4. So I get x over negative 1 plus x minus 2. Now, what is this whole thing supposed to simplify down to be? Just x. Am I ever going to get there?
No.
No. So at this point, or whenever you realize that no matter how much I keep messing around with this, it's never going to turn into just an x. I can stop and say, all right, no, they're not inverses of each other. It did not simplify down to just be x.
I don't like the loop of fractions.
When it does, when they are inverses, it actually usually works out pretty nice because everything just kind of cancels away. So I don't know if 8 is or not, but 9.
12's the girl.
Let's try. Oh.
12's looking a bit
You know what? Let me cheat for 1 second and look at the answer key and just see which one is, so then we don't have to. Yeah, just a little. Well, not a cheat, a helpful hint.
It'll never hurt, right? Cheating doesn't hurt.
Oh, yes, it does. Algebra 2, CPA. What did I call this? Worksheet 7-7.
fourth grade stuff. Yeah. There's like 6th grade to 12th grade. So
Okay, perfect. Let's try number, who knows? I don't know if this one's going to be a yes or a no. I have no idea. But we're going to try number 8.
Do you have tissues?
Yes.
Swiping it out. I might. Try to see something.
All right, guys, let's try number 8 together. You ready? Everybody's ready? So we're going to take one and we're going to stick it into the other. So I don't know. It doesn't really matter. Let's take this one. And I'm going to stick it into that one. Give yourself some room. There may not be enough on the sheet. So I now have 1 over. Instead of writing that x, I write all of this. And then I still have a minus 1, minus 2. So first of all, I want everybody to make sure that they understand why I wrote down what I wrote down. Everybody's all right? Okay.
I do know one question.
Yeah.
Oh no, never mind. I figured it out now that I look at it.
All right. Now, check this one out. You ready? You ready? You ready? So, first of all, plus 1 minus 1, well, that's easy. That's just gone, right? Plus 1 minus 1. See you later. And now, I have a fraction and a fraction. I'm going to do keep, change, flip. Keep the numerator. Change to multiplication. Flip this over. X, oh yeah, sorry. X plus 2 over 1. Well, 1 times that, isn't that just x plus 2? Oh my gosh, don't I just have x plus 2 minus 2? So don't I just have x? See, so when they are inverses, it's a really good sign when everything just sort of cancels. Well, it has to cancel out because you have to just be left with x. So when you are doing a problem and nothing's really canceling and it's becoming a lot of work, that's usually a no, they are not inverses of each other problem. Let's try one more together. Yes?
Can we do 12?
No, but I can do 9 or 11.
11.
11, okay. So let's try 11. Ready? So let's take, I think it'll be easier to take this one and stick it in there. -6 times -5x over 3 plus 4 all over 5. Does everybody see why I wrote what I wrote?
Yeah.
All right, cool. Now I just want to simplify and see if this will simplify down to just be x. So negative times a negative will be a positive. That's just a 2. That's just a 10x, right? 10x plus 4 over 5. Is that ever going to simplify down to just be x? No. So this one I get to stop pretty early because it's clear I'll never get down there. So no, they are not inverses. Isn't this kind of fun?
No.
Yes, I knew you would agree.
Oh, great. Thanks your phone.
Of course you can, any old time.
Use it
You
in
have
front of
ghost
my
stories?
class right now.
Yeah, you have to go.
Oh yeah, I
No,
told
have
them.
ghost stories.
Yeah,
I can't tell. Mrs. Brady's covering the class right now, so I can
she doesn't have time right now.
Tell one.
When you're trying to get it, so you can keep change. But like I have 1 over
I'm playing.
4 over x minus 1.
You have to get them together.
How do
So what's your denominator?
4 over x minus 1.
So put this as 1 over 1, right? And then multiply by x over x. So now your new denominator is 4 minus x all over x. Do you see that? Right, if you put them together. So now when you flip it, you have one single fraction to flip. All right, guys. So your homework is the rest on both sides. Huh?
Have you ever went to read Arabic?
I know you go from right to left. No. We read left to right. Don't they read the other way? Oh, yeah.
Miss Sabia, on number 2,
You want to read some?
would y be negative?
I wouldn't know how. Would y be negative on number 2?
Can I go on?
All right. Thanks.
No problem.
I have another question.
They are white 30.
I guess.
Prairie.
Yeah.
Get done. Trust.
X over 4 minus x.
Milk
That's
more
not
than
going to
you spoon with
simplify to
water.
x ever, right?
X over 4 minus x?
Yeah. And then
No.
plus 1 on the side. That's never going to go to x.
A plus 1.
The cow is black.
Let me try one thing. Because what if we, instead of saying plus 1, we did plus 4 minus x over 4 minus x? So it'd be x plus 4 minus x over 4 minus x. So those are going.
Kill the lion.
No. Okay, so we're clear on the homework. You're finishing all the problems that we didn't do on both sides?